Scientific notation is a way to write either very large or very small numbers. So on the left I have just a review of powers of 10. 10 to the power 4 is 10,000, 10 to the power 3 is 1,000, etc. all the way down to 10 to the minus 4, which is 1/10,000th, or 0.0001. Now you can go a lot further up, bigger numbers, or a lot further down to get smaller numbers. The basic format for scientific notation is one of these two ways here. You have a number, a, times another number which is a power of 10, 10 to the power of b, or instead of writing the little x for multiplication, you can use just brackets to indicate multiplication. Now the rule is that that first number, a, has to be greater than or equal to 1, but less than 10. So it's essentially only one digit to the left of the decimal place. And then the exponent on the 10 has to be an integer, either a positive integer or a negative integer. So here's an example, 3240, 3,240. Now, to convert this to scientific notation, you would first want to write it as a number between 1 and 10, 3.24, and then ask yourself, what do you need to multiply that by to get the original number, 3,240, and you need to multiply 3.24 times 1,000. We don't need to write the trailing zero on 3.24, and we can then convert the 1,000 into a power of 10. So you would write this as 3.24 times 10 to the power of 3. And the 324, these are sometimes referred to as significant figures. So these are significant. And we could say, if this were a measurement, this is accurate to 3 significant figures. So the idea there is that those initial numbers are more important, really, in some way than the size of the number. A small number like 0.0028, again, you'd want to write it first as a number between 1 and 10, 2.8. One trick to doing this is to ask yourself, how many times do you have to move the decimal place over? There's 1, 2, 3, and so you could just simply write this as 10 to the power of 3. But since it's gone the other way, this would actually be 2.8 thousand, or 2,800. Since you've moved the decimal place the other way, it's really 10 to the power of negative 3. Now, I've used actually reasonably small large numbers and reasonably large small numbers here for the example. Scientific notation can be used to represent really, really big or really, really small numbers. For instance, the number of water molecules in 1 gram of water is approximately 3.35 times 10 to the 22. So that's an enormous number, obviously, even though we're only dealing with 1 gram of water. Or even more of a kind of a round number, but a big number, one estimate for the number of atoms in the universe is 10 to the power of 85. So you could think of this as 1 times 10 to the power of 85. It's such a gross estimate that we don't really need that leading number. We just have the power of 10.